Okay, this is the video on collision. So when we think of collision problems, we have to think of momentum as well. Momentum is P equals mv. Um, so there are two different types of collisions. Well, first off, let me say we're going to use the conservation of momentum to solve these collision problems. But there are two different types of collisions: elastic versus inelastic. Elastic collisions are when objects collide and they bounce off of each other, whereas inelastic collisions are when objects collide and stick together. So they have two different conservation of momentum equations just to account for the difference in mass before and after, and so on and so forth. So for the elastic collisions, I don't know if you can see, but it's kind of sloppily written, but the equation is mv1 plus mv2 equals mv1 plus mv2, whereas the inelastic collision, the equation is mv plus mv equals m plus mv. Does that make any sense? Yeah. Okay. So I wrote out the equation beforehand just to save a little bit of time. So ball A is 1 kilogram, and it collides with ball B, which is motionless before the collision. Ball B is 2 kilograms. So ball A strikes ball B at an angle of 60 degrees. What are their velocities after the collision? Okay, so this is the diagram that they gave me. So ball A strikes ball B at 60-degree angle. So now when we have angular collision, we have to separate it into x and y components. So they gave us 60-degree angle. Use a different color, in which we can make a triangle, a right triangle. So what we're gonna do is take this triangle out. So this is 60. So we have our handy dandy 30, 60, 90 triangle, like we always do. So we know that across from the 30 is always the smallest, the hypotenuse is always 2 times the smallest, and then the adjacent is always the smallest root 3. So we know from the equation that our angular momentum, or our angular velocity, is 12 meters per second. So that our hypotenuse, which is 2x, so we can say 2x equals 12 meters per second. And since we know that, we can say x equals 6. So x equals 6, and x equals 12. And then we can say that the adjacent velocity is equal to 6. Write that a little bit better. 6 root 3. So now we have our sides. And our velocities of each side are velocity to the right, which is 6 root 3. And then our velocity in the vertical direction going down. So 6 root 3. And then 6. So now we have that. The second thing that we want to do is find our momentum before the collision. So we'll go to step 2. So just as a reminder, momentum is mass times velocity. So since we separated into x and y, we want to find momentum we'll start with ball A. So we'll say A. So we'll just say momentum in the x direction is px equals mv equals mass. So in the video, Regan, you put the mass as 2 for ball A. I don't know if this is correct or if it was a mistake or if I'm not understanding something correctly, but I would assume that the mass would be 1. But we're gonna go with 2. That's what Regan did. times the velocity in the x direction. So that's to the right, times 6 root 3 gives us 12 root 3. P to the y, so this is the negative vertical direction or downward direction. And V equals, the mass is 2 once again, and then the velocity in the downward direction is 6, so that gives us 12. So we found the momentum before the, so we gotta do ball B. Now, ball B is motionless, so P equals 0. Okay, so now we found the momentum before the collision. We have to go, what we need to do is assess the directions and that the balls move in the diagram to see where the momentum goes after the collision. So let's split this up into X and Y so we can get an idea of where this momentum is going. So after ball A hits ball B, we see that there's no more momentum in the X direction, but all the momentum goes into the Y direction. So the Y direction, let's see.